Hello everyone, this is the third lesson recording for IM2, April 26, 2021. So now we're going to be talking about arc. We've talked about central angle, and we've talked about sector. We're going to be talking about arc. What is an arc? Arc is a portion of the circle's circumference. So remember, sector is a portion of the circle's area. Then arc is a portion of the circle's circumference. Circumference is the outside length, remember? And what is the portion of the circumference is the red arc. Okay, what portion of the circumference is the red arc? Well, it's pretty much the same thing as we've been doing for sector. To figure out what is the length, okay, an arc is, we're talking about the portion of the circumference. We really take a fraction of the whole circumference, and in this case 180 degrees is like half of the circle, right? Or 180 degrees is half of 360 degrees, which is the whole revolution. So we're really dealing with half of the whole circumference. What about this? If you're told that it's going to be 90 degrees, what portion of whole circle's circumference do we have? 90 is a quarter of 360 degrees. So we can say it's a quarter. Okay, and that's half is 180 divided by 360, and a quarter is 90 divided by 360. And what about 140? Okay, 140 is really 140 divided by 360, which we can simplify by dividing both top and bottom by 10, 14 over 36, and since 14 and 36 are both even, we can divide by 2. So 7 over 18 is the simplest fraction that we're dealing with. Okay, so then which red arc is the longest? Okay, we're talking arc. When we're talking about arc, we're talking about length. So which is the longest? Well, we can only tell when we know what the full circumference is. So we need to figure out what the full circumference is for all of them, right? So it's just like the sector. We need to figure out which is the bigger area. We need to know the radius or diameter length, and likewise for here. So now this time, if you're told what the radius is, now we can figure out what the arc length are. So arc length, and we can use S as the arc length, is whatever proportion that we have. We have half of a circle, or we can think of it as 180 divided by 360, or visually this is half, right? Or this we can say half, which is 180 over 360 times what is the whole circumference is 2 pi r. In terms of r is 2 times pi times r, which is 8, and this is same as half. We do know that. So this is same as 1 over 2. And so half of 8 is 4, so this is going to be 8 pi units of length here. What about this? We have arc length to be, well 90 degrees is same as 1/4, so I'm just going to use 1/4, okay? Multiply by 2 times pi times r, which is 12. And a quarter of 12 is 3. 3 times 2 is 6 pi. Then finally for this, now we can't visually tell the fraction or the portion of the circle we are dealing with, so we are going to use what we do know, which is the angle measure, central angle measure. It's 140 degrees divided by 360. Multiplied by 2 times pi times r is 8 here. Okay, so then I can simplify the fraction as get rid of the zeros by dividing by 10, and then divide by 2, so it's 7 over 18. Now can I simplify any more? Okay, I know that 18 and 8, I can divide both by 2, so it's going to be 9 and 4. I'm making the numbers smaller so that I can even do all the multiplication in my head, because that's going to help me come up with the exact answer. So 2 times 4 is 8, 8 times 7 is 56, divide by 9, pi is what I have, and 56 divided by 9 is how many 9s go into 56? 6 times 9 is 54, so that leaves me with 2 over 9 pi. So 6 whole and 2/9 of a pi. So which is the longest length? The one A is the longest length, B is the shortest, and C is the middle. So please take notes on this. The length of an arc S, we use the letter S for the arc length, is also a fraction of the circumference C. So the central angle theta of the sector also determines the fraction. Therefore, S is calculated as theta over 360 degrees multiplied by C, that's the circumference, which is theta over 360 times 2 pi r, where theta represents the central angle, r represents the radius, and S represents the arc length. So please take these notes and draw all the diagrams. Now find the length of the red arcs. Okay, so how do we do that? Can you try to do it yourself now? And when you have your answers, you can tell me in private chat. Alright, I'm assuming you had a chance with both of them. Here is my answers. Okay, so S is, we're dealing with 50 degrees. Out of the whole is 360, so that's the fraction that whatever is the total circumference, we're going to multiply that, because that's the representation of portion of the circle we're dealing with. So that simplifies to 50 times 15 times 2 divided by 360, and you can simplify this fraction as 25 over 6 pi. For B, again, we're dealing with 220 degrees out of 360 times 2 pi times 10, and that simplifies to 110 over 9 pi. Now you're going to be moving on to the decimals activity. That's time number 10 to 14. Okay, some people buy pizza just for the crust. That's me. The total length of the crust on this personal pizza is 24 inches. Drag the black points to create a pizza that has 8 inches of crust. Okay, so we're really dealing with, I just want 8 inches out of the possible 24. So what portion are we talking here? We're really talking about 8 over 24. 8 over 24 simplifies to 1/3. So that means we're really dealing with 1/3 of total of 360 degrees. So how many degrees do I want? So if I divide 360 divided by 3, that leaves me with 120. So that's 120 degrees. So I want 120 degrees of pizza. So I am going to move this to 120 degrees. Where is 120? It should be here. And visually you should be able to check that this is 1/3 of the pizza. When I check it, that is correct. Okay, now the circumference of this circle is 15 units. Enter an angle expression to create the arc with a length of 13 units. So I want 13 out of possible 15. So I want the fraction to be 13 over 15 of the total circumference. Okay, so enter the angle expression. I want 13 over 15 of a whole circle, and the whole circle, we're dealing with angles, so we're going to be multiplying by the total whole angle is 360 degrees, and that's what I should be entering. And you should be explaining something like, well, 13 over 15 is the portion of the circle that I'm interested in. So, and the whole circle revolution angle measure is 360, so that's what I'm multiplying by. Okay, let's try backwards. The circumference of the circle is 15 units. This time you will see a sector cut out at an angle of 144 degrees. Type in the value of expression for the length of the arc. Okay, so we're really dealing with 144 degrees out of the possible 360 degrees, right? So that's the portion that we're dealing with. So that's the whole part, 144 degrees. Why is it not coming up? 144 divided by 360. That's the portion that we're dealing with. Okay, and because we're dealing with, that's the angle measure. So it's 144 degrees divided by 360 degrees, so that becomes just 144 divided by 360. Now we're talking about the circumference length. Okay, we're dealing with length, and so we're multiplying that by what is the total circumference. That's going to be 2 times pi. You can type in pi and pi times r. What is radius? Okay, what is the radius in this case? Oh, my bad. We're given the circumference. We are not given the radius. So instead of 2 pi r, I am going to be multiplying it by 15. Okay, because that is the whole circumference. And when I do that, I should get a nice work response. Now this time we're being asked to find the slice area. So we're looking for the sector plus cross length. Cross length is the arc length, right? And we're dealing with what portion of a pizza. We're dealing with the pizza is divided into 8 pieces, so 1/8 of the pizza. And the diameter of the pizza is 10 inches. So that means the radius is 5 inches. So slice area. How do I get the slice area? Area is going to be, what portion are we dealing with? We're dealing with 1/8 of the pizza. And what is the total area for the whole pizza? It's going to be pi times r. R is, the radius is half of 10, so that's going to be 5 squared. Okay, and that's going to be, okay, and I get that correct. That's the correct response. And then for the arc length, for the cross, how much of cross do I have? I have 1/8 of possible total circumference length is, total circumference length is 2 times pi r, or diameter times pi. So diameter is 10 times pi is what I want, and I get the correct response there too. Okay, so this is the final challenge. What is the perimeter of the sector? Okay, so perimeter of the sector, we're really dealing with a slice of that pizza. The radius is 8 units. The angle sector is 40 degrees. So that's what we're taught. So we're dealing with 40 degrees, and the radius is 6. Okay, so how can we figure out the perimeter? Well, to do that, we need to figure out this length, don't we? We need to figure out, oops, we need to figure out this length. What is this length? That's going to be 40 out of possible 360 degrees multiplied by the whole circle's circumference is 2 times pi times 6. Okay, is that all? No, we also need to add this length and this length here as well, because that's going to the perimeter. Perimeter just means outside length. So I have 40 divided by 360, because we have 40 degrees out of possible 360 degree. That's the whole revolution, times 2 times pi times 6. That gives me this length. But to that, we also need to add this length and this length. So that's 6 plus 6 right there. And that gives me the right answer. Finally, you are supposed to take notes on some notations to say to refer to this circle, we would say circle Q. To refer to this FG, the arc length, we would use